Hi everyone, we are going to solve homework 2 questions in this video. So we are given this relational schema. We have some articles. So for each article we have a primary key, article ID, a title, the content of the article, you can think it as a long text. We have the writer ID as a foreign key. So this writer ID is referencing the writer table. We also have a view count for the article. You can think it like a news article. So every time the people views it, this is going to increase. So for each writer, we are again using a primary key, writer ID, name and surname of the writer. We are keeping the date of the birth as a date time. So instead of age, we are keeping the birth dates. There is the phone number and the salary. For categories, so articles are or let's say it like that. So each article is going to be in one category. Using the relation in category, we are relating one article with some category. Using this category ID, we have names and descriptions for the categories. We are keeping users, and users are able to comment on different articles. So for each user, we are keeping some user information as well as again the date of birth, and the comment relation is going to relate one user to a specific article with the text of the comments. So we are given these questions and we are going to try to solve them. So for the first one, and also maybe it would be useful to have a separate copy that shows the relational schema as well. It will be better. Okay. So for the first one, find name and salary of the writers that are paid more than 3,000 in a month. So this is one of the easier ones. Everybody was able to do it. This is going to be a simple projection. So we need to select name and salary. So if we are to look at the writer table, we have name and salary directly. These are going to come from the writer table. And our only condition, we write it next to where, is for the payments. So for the salary to be larger than 3,000 in a month, we are saying, and if you read the description, the salary is given as the payments in amount in terms of Turkish liras. So everybody was able to do this question. Maybe I should also put the numbers somewhere. So for the second one, in this question, we would like to see that you are able to use the parameters within your SQL queries. And we also would like to see that you are able to use functions. You are able to project the results of functions. So we are given a parameter, USD to TL. This is the current exchange rate for converting dollars to liras. We would like you to find the average salary of the writers. So again, a selection query. This time we need to project the result of some function, the average function. And this is going to be for the salary. We have some condition, but the result should be in terms of dollars as well. So instead of just directly finding this salary and projecting it, I can also multiply it with something. So this is Turkish liras, and we are giving the rate for dollars to liras. So basically we need to divide it to this parameter. But if you made if you consider that as TL to USD, we also accept it. So as long as you are keeping some sort of logic, we wanted you to use the average function, and you should apply this parameter to the projection result as well as, so we are again inside the writer table. Salary is in just the writer table, but we have the condition. So the condition is for the average, so we are projecting the average salary of the riders that are paid more than $500. So this time the salary, so we can write something like this: salary should be larger than 500, but this should be dollars. So this is liras, this is dollars. We need to use the same currency. Either you can divide the salary to USD to TL, this parameter, or you can multiply the one on the right as well. So we accepted both of them. Some people try to convert this into an update query. So this question is not saying you to update some of the table results, some of the values, or let's say. So this is just going to be a projection query. So we need to be careful about that. So for the third one, find the title of the articles that contain the word data in their content at any place. So if we are to look into the article table, there is content. If you read the description, it is saying that the content is a text. Whatever is written in the article, it is going to be a long text. It is a string. We would like to search this word data, and if it appears in any place in this text, then we would like to get this article's title, otherwise not. So we are going to project the title of the articles. So article title, it is going to come from the table article, and we have just one condition saying that okay, the content, this attribute, we are going to use regular expressions. It should be like this string. So that string is star data star. So it could start with any number of any characters followed by the string data, and it could be followed by any number of any characters. So this is the version that we learned in the lab. In some sources, this regular expression sign for any number of any characters, they might use the percentage sign as well. So we also accept it. And there is also some SQL keyword contains that does a similar task. We also accepted that, although we did not show it in the lab and in the course as well. I don't think that we are showing it, but we also accepted that. But in the exam, be careful. So in the exam, we expect you to do such tasks using the things that we have used in the class. So it should follow the similar, let's say, mindset. So for the fourth one, the different thing is that we need to make a deletion query. It is not a projection this time. So I need to start with delete from, and then the table name, we are deleting from the table comment, right? So delete all comments. So I need to delete from the comment table. So I guess this is again a keyword, that's why it's changing the color, but this is in our case the name of the table. And we have a var condition, and our condition is that the word of the comment, the comment text, it is again some paragraph, it could be a long text. If it is containing any of these words at any place, we should delete this comment. So again, similar to the one on top, but this time we are comparing the comment text using the keyword like. So if you use the equal sign, then it's not going to do it, because with the equal sign it only looks for exact matches. You cannot use regular expressions. You need to write it like the keyword like. So star discussed star, so it can start with any number of any characters, but discussed is going to appear at some place. Or another condition, and yet another condition, and these are going to be for anger and hate. So these comments, we would like to delete them. If they are like any of these, we combine it with the OR, the logical OR operation, so that any of them appears, we delete that comment. So the fifth one, find article name and view count of the articles written in the category sports. So this is again a simpler one. We just need to be careful. So find article name and view count. So article name is inside the article table, and the view count is also inside the article table. We just need to relate it to the categories. The category name is sports, and to relate one article with one category, we are using the relation in category. So I need to project the article title and also the view count, and this is going to come from the article table. But to find the corresponding category, I need the relation in category, and I also need the table category, because the name of the category is inside the category table. And to relate one article with the category, I need the relation in between. So these are the tables that we are including. And then we need to write our conditions. And our conditions, so we can first start with the category name. So there is just one attribute called category name. So I can just directly write, okay, category name should be exactly equal to sports. And I'm going to use the logical AND operation because I want these conditions to appear at the same time. The other conditions are going to make the join operations. So if you use QBE, it is going to generate some SQL code automatically, and it is going to use the keywords like join. But in the lab, when we were like dealing with the SQL code directly, we specified the join conditions next to where. So using where conditions, we can also make the join operation. In this case, on the article side, there is the, if you look at the in category table, the article ID of article and article ID of in category should match to make the join operation. So I'm going to write that now. Article ID of the article should be equal to the in categories article ID. And I have another condition, so this time on the other side, the category IDs should match. So inside the in category, the category ID, it should match with the one in the table category. So these two are my join conditions. So in this question, the important part was to be able to do the join operations. Otherwise, this is just a simple where condition. So to make the join operation, you should include those tables and also specify how you are joining them. Otherwise, it is going to be just a Cartesian product. So continuing with the sixth one, find name and phone number of the writers that have at least 5 articles. So this is kind of one of these like a little harder ones. So you need to be able to count the articles of the same writer. So at the end, we are going to project the name and phone number of the writer. So we can maybe start with what we are projecting, the name of the writer and the phone number of the writer. So it should come from the writer table. Otherwise, in other tables, we do not have these attributes. But that writer should have at least 5 articles. I need to put some condition on groups this time. So if you look into the article table, so in the article, we are talking about articles. The writer should have at least 5 articles, larger than 5. So in the article title, I know that which article is written by which writer. So we do not have a separate relation in this case. Inside the article, I keep a foreign key that references the writer table. So if I leave this for now, if I were to look at the table article, so let's say in a separate SQL, I'm selecting something out of the article table. If I were to group according to the writer ID, so think about it. We have in the article table lots of articles that are written by different writers. If I were to group them according to the writer ID, in each group, I can count the number of articles that's written by this writer. And I can put some condition for the groups. So if I am putting conditions on the groups, I use the keyword having. So for each of these groups, I can find the count with any of the attributes. And if this count is larger than 5, I can get the writer ID of such cases. So one mistake people did a lot in this case is if you are grouping according to something, you can only project a subset of the things that you group by plus the aggregate functions. So in here, I cannot add the table writer and make a join operation and then select the name and phone number. So I should be careful about that. One other mistake, sometimes people try to use the where condition for results of functions. So if I'm inspecting on the groups using a function, I need to use the having statements. So this is going to be my subquery. And out of that subquery, I will get writer IDs. And in the outside part, I'm going to write a where condition. Okay, I know the writer IDs. So these writer IDs should appear in this subset. So out of this subquery, there could be many writer IDs. Therefore, I need to use the keyword in. I cannot use the equal sign directly because if it returns just one entry, there is no problem. But if it returns multiple things, we get error. So if it has the possibility to return more than one result, we need to use the keyword in this outside part. So then if I know the writer ID, I can directly get the name and phone number of such users. We do not have any other conditions. So it is just saying that, okay, this writer should have at least 5 articles. Some people like created, or let's say some people find and projected the count as well and did some other subquery and then find the ones that are larger than 5. That was also okay. We accepted it with like no reduction on the grade. But for this question, the important part was to be able to use the group by, to be able to put some having conditions. And you should also know that when you group something, you can only project a subset of it plus the aggregate functions. So then you need to make some other join operation and use the group by part as a subquery. So for the 7th one, it's saying that list each category name along with the average view count of the articles in that category. So if I were to just list the category names, then I can just use the table category. But I'm also interested in the average view count of the articles in that category. So let's start from somewhere. Let's say I'm projecting the name of the categories, which is the category name. I'm going to add something more, but let's say we are getting information from the category table. And we also need to use the average view count of the articles, which is inside the article table. So I need to also make the join through in category and the article tables. So I'm going to include them as well, in category and the article tables. Since I include 3 different tables, if I need to join them, I need to specify them as the where conditions. Otherwise, it is going to be the Cartesian product. So I know that how to join these multiple tables. So I'm going to just copy it from this part. So on this article part and between the in category and article IDs should match, and between in category and category, the category IDs should match. So this is my where condition, but I also need to inspect something about the view counts. So I have each category, and for each category I made the join operation. So now I have, like, for each category I have the corresponding article. You can think it like article number 1, it's in category something. There could be multiple articles in the same category. We all have those. I need to group them according to the category name, because I'm inspecting the category names and the average view count of the articles in that category. So I need to group them according to their categories. The most correct way of doing it would be to group according to the group according to the primary keys. So grouping according to the category ID would be the most correct solution. We are not saying that, but the category name kind of feels unique in this context as well. So if you grouped according to the category name, we accepted it as well, and it is doing a simpler solution. So if I were to say group by the category name, so for each group, if the category name is unique, I can group them accordingly, and I can write the average of the view counts directly. So this is correct. Since the category name is most probably unique as well, but we are not specifying it, so the most correct solution would be to group according to the category ID, but then based on the rule saying that, so if I'm grouping according to the category ID only, I cannot project category name. Then I can only project the category ID. Then I would need to get this as a subquery and make the join operation to get the category names as well, if the category name is not unique. If there are multiple categories with the same name and they, let's say, have different articles in them, so they would have different average view counts, then I would need to select the category name this time, and I would need to rename this calculated attribute as something, let's say VC for view counts. I'm going to project it as well in this part. I'm using the category table, and I'm also including another table which is the result of this subquery as some table name, let's say res for results, and I'm going to include a condition saying that, okay, from the outer part we can also give a name to simplify it. In this outer part we have category C dots. For the category we have the primary key category ID. This category ID should match with the one that is coming from this result set, which I renamed as res, and inside there we have this category ID. So given that these are matching, I can get this VC to project it. I can get the category name from C, because it is not coming from res. In res I have only the category ID and also the VC. Therefore I don't need to specify res.vc in this part as well. So the most correct solution would be this. And if this was like a more common thing, like the name, so category names are most probably unique. But if it was like something name of the persons, people, so it would be problematic to just group according to the category names or names in that case. So if you are able to do it, the better is to use the primary keys to group accordingly. So for the 8th one, it is saying double the salary of the writer that has the highest article count. So this question is very similar to one we did in the lab. So the advanced SQL lab, we had a very similar question. The important parts, first, we are not projecting, we are setting something, we are updating, right? We are going to say update the table name is going to, for the salary, where salary is included, it's inside the writer table. So we need to update the writer table by setting some value. We need to set the salary to be the double of it. And we would have a condition for the writers. And my condition is for that writer to have the highest article count. So keeping this aside, let's first try to find the article count of each writer, let's say. So I can write something like this. I can select the count looking at the table article from the article table, and I can group these accordingly. I can group them according to the writer ID. So in this part, let's say I also project the writer ID and the count as, let's say, this is going to be the article count, let's say AC. So if I group according to the writer ID in the article table, for each writer, I can get the count of the articles for that writer. And I need to find the maximum of this AC. So like there are lots of different ways to write it. So we can include the max in this position as well. But let's try to keep it more generalized. So I'm going to say, okay, this is yet another result set. Let's call it res. And within that result set, I can select the maximum of AC from this result set, which I call res. So this is my subquery. It is going to return a result set. I'm using it as a table, similar to a table. I renamed it as res. And from that result set, from that table, I look at the maximum of article counts. And since I'm just using a function, I know that this is going to return just one value. So this subquery, it is going to just return one value, and it is going to be the count of the maximum of the counts of the articles. So for each writer, we have some count of article, some number. Ali wrote 7 articles, Hassan wrote 10 articles, for example. The maximum is going to be the 10. It's Hassan's article count, but we just have the maximum number yet. So I need to be able to find the writer ID as well, because in this part I'm unaware of the let's say the number of articles. In an update query, I should not use the group by. I should just get the writer IDs. So I would say like writer ID in this subset. So I need to find some such query that is going to return me the writer IDs of the qualified people. So out of this part, I already said that I need the writer IDs. So I need some writer IDs, and they are going to come from the article table again, because I know the writer ID plus how many articles we have in that part. And again, if I say here group by the writer ID, it is very much similar to this subquery. So I already did that. And I'm going to put some condition saying having the count of articles this time. It should be equal to the maximum amount. So I know that this query was returning me just one value. It is the maximum amount. So then I could write such thing. So if I were to like write it in a better form, so okay, so in this part, let me also make it kind of larger. In this subquery, I know that I group the article table based on the writer ID, so that I have the writer ID. Next to it, I have the number of articles that are written by that writer. I rename that table as res. This is just similar to a table. From there, I can find, so this is like res.ac, but since this attribute only appears once, I can directly refer to it. So I find the maximum of these ACs and I project it. So out of this part, it is going to be just some number. And if I were to look at this subquery, again, I'm doing the similar thing inside the article table, group according to the writer ID, and look at the count for each of the groups. If it is equal to this number, which is the maximum amount of the count, then get those writer IDs. There could be like multiple people with the same amount of articles. So that's why I'm using the keyword in again. And this is my result sets. So the writers that qualify for salary updates are in this result set. These are the writer IDs of them, so that I could just write where writer ID in this result set. So this was like very much similar to the one that we did in the lab. And the important part is to like compare the matching things. Some people find the maximum but try to like okay, some people like first try to find the maximum of something. Some people mistook it as the view count. So this is not about the view count. People are writing articles and we are counting the number of entries as articles, but the view count is something different. It's like how many times that one specific article is viewed. This question has nothing to do with the view count. So some people try to find the maximum of the view count, try to compare it with some other things, etc. Some people wrote writer ID in this part, but tried to match it with the maximum amount of the count. Again, we had like problems. So there are like different ways of solving it correctly, but you need to like compare the right things. You need to make the like group by operations. Without the group by operations, we cannot find the counts for separate groups. So you need to be like careful about it. For the ninth one, it is one of the simpler ones. Find the title and the content of the articles written by a writer named John and in category business. So we already actually solved one for category sports. We can like copy it from there, I guess, as a starting point. So I am selecting this time the title, okay, article title, and the content. So this time project content. I need the article in category tables to relate them to categories, and I also need to relate them to the name of the writer. So I need the writer table as well. So I'm handling the parts about the category. For the category name, I need to use the business. And my conditions would continue. Okay, I need to join the article to the writer. I can write article dot, if you look at here, article dot writer ID, it is the foreign key that references the writer ID that's inside the writer table. This should match. And my new condition is for name of the writer to be John. Name equals John. So this is what I need to do. So the important part is to make the join operations, but this time for more than 3 tables. It is for 4 different tables. Some people use the the join keywords. That's also okay. You can like do some intersections, etc. But this is like the most basic solution, and I guess the most basic solution should come up in your mind at first. So no need to make it a long one. But lots of people like traveled a long way to solve it. They solved it correctly, but this is like the simpler way. We just project the required things. For these 2 things appearing at the same time, we have the and. If it was saying or, we would like combine them in a different manner, etc. So the last question is like a little one of the harder ones. Find the average view count of the articles that has a comment by at least 1 user that is 18 years old. But if we just keep it like that, it's simpler, but we have a note saying that if an article has comments by multiple users of age 18, you should include it only once. So like we are trying to clarify it. So we are looking at the average view count of the articles. In some way around, if you make the join operations, you might get the articles matched up with the commenters. And if there are multiple people with the specific age that commented on this article, there is risk of including it more than once. And it might disrupt the average view count of the articles. So we are this time looking at just one number. So it is saying that there are like, let's say, lots of articles. In some of them people are commenting, and in some of them there is at least 1 user that is 18 years old. So for each of those articles, find the average view count. So we are maybe we are going to give some commercial, some ad to that newspaper, let's say, and we are trying to find out whether how many views the articles get if they are commented by these age group, let's say. So let's try to show it. So solve it, not show it. I'm going to solve and show it. We need to find first, this is a selection query. Why the color is not right, I'm not sure. Okay. No. Oh, okay. Since I forgot this quotation mark. It was not coloring it correctly. So a projection, I need to report just one number, which is going to be the average of the view counts. So let's write it like this for now, but we are going to probably change it in some place, or maybe we do not need to. Okay, let's see. This is going to come from the article table, because view count is only inside the article table, and these are going to be only for some specific articles. Okay, let's do it like this. It is going to be only for some specific articles, and those specific articles would be included in some result set of a subquery. Let's try to write that subquery. So my only condition is that, okay, this article should get some comments. So article comments. In the comment relation, we connect one user to an article, and the date of birth of that user is included in the user table. So if I were to relate the article ID, so I need the article ID. If I need to relate some article ID to a date of birth, I need to include the tables comment and user. So I'm going to select something, and they are going to come from comment and user tables. I'm going to select something, keeping it for now. Actually, I'm going to get the article ID, because article IDs should match. I'm going to get the article ID from the comment table. Since I include more than one table, I need to use the where condition. On this comment side, I have some user mail, and that user mail should match with the one that is inside the table user. So these two should match. This is one of my conditions, and that comment should be made by an 18-year-old. So I need to put some condition on date of birth as well. Actually, this I guess this was not that hard, but some people made it hard. So my other condition, date of birth, the person should be 18 years old, and I have the date of birth. So you can like base the current time, etc. You don't need to use any functions. You can just directly use the today's time, for example. So most people like forgot, so we did not care about it. If you are putting a date in SQL query similar to quotation marks for strings, we need to use this hash symbols, but we did not reduce any points for that. So today, let's say 13/04/2020. So we are able to compare dates like this. And for our 18 years old, you can like directly do the math, and you can say that, okay, 2002, date of birth should be, you can use the between keyword as well, or you can say, okay, it should be smaller than that. So if the person was born on today, let's say on this day, would be 18 years old, and up to like in a 1 year range, let's say. So this part should be larger than. So 2002 is larger than 2001 in terms of the date. So closer to the today, it is larger. So I'm saying it should be larger than this date, and it should be smaller than this date at the same time. I'm using the AND conditions, and the other condition is making the join operation for comment and user. And I guess these are like some keywords, that's why they are in blue color. This is my subquery. it makes the join operation. So the let's look at the important part. So I could have just joined them on the same page, on the same parts, but then I have multiple instances of the article for each matching user of age 18. But I don't want that. I would like to inspect on the view counts of the articles. Each article should appear once. So some people try to solve it using the keyword distinct. That's also okay. But the simpler one is this. I get the article IDs out of the subquery, and I know that for each of the articles it is going to be appearing just once, because I'm using the keyword in. So out of this subquery there could be article IDs with the same number. So for each of the matching users I made the join operation, I put the conditions. For article 7, let's say there are 3 different comments, 7 would appear multiple times in the subpart, but since I'm saying in here, for 7 it is going to only match once, so it is already distinct. No need to say select distinct article ID for this. But with some different setups you can like add the distinct to solve it. But if you were to like get rid of this part, if you were to add everything to the from, if you try to do it without a subquery, then it is going to be a problem. So for the articles, if you have multiple comments by a user or different users of age 18, we do not want to get them inside the average multiple times. So then it would be like a weighted average. And that's it. So we have these solutions. So again, they are not the only way of solving them, or not necessarily the best way. So the best way is actually how you can do it. But in some of them, in your solutions, people complicated it. So you should not complicate it without the need. So if you try to include everything you know in a query, so in some question, I do not remember which one, but people included the group by additionally. So in the night one, for example, if I add group by and if I group according to something, it is not going to be correct. So adding everything is not the solution, so you should be careful about it. See you later.